The surface of the Earth is far more beautiful and far more intricate than any lifeless world. Our planet is graced by life, and one quality that sets life apart is its complexity, slowly evolved through 4 billion years of natural selection. You can describe in detail how a rock is put together in a single paragraph. But to describe the basic structure of a tree, or a blade of grass, or even a one-celled animal, you'd need many volumes. It takes a great deal of information to make, or even to characterize, a living thing. The measuring rod, the unit of information, is something called the bit. It's an answer, either yes or no, to one unambiguously phrased question. So, to specify whether a light switch is on or off requires only a single bit. To specify something of greater complexity requires more bits. There's a popular game called 20 questions, which shows that a great deal can be specified in only 20 bits. For example, I have something in my hand. What is it? Is it alive? Yes, 1 bit. Is it an animal? Nope, 2 bits. Is it big enough to see? Yep. Does it grow on the land? Yes. Is it a cultivated plant? Nope. Well, with only 5 bits, we've made some substantial progress to figuring out what it is. With 20 skillfully chosen questions, we could easily whittle all the cosmos down to a dandelion. In our explorations of the cosmos, the first step is to ask the right questions. Then, not with 20 questions, but with billions, we slowly distill from the complexity of the universe its underlying order. This game has a serious purpose. Its name is science. Out here in the great cosmic dark, there are countless stars and planets, some far older than our solar system. Although we cannot yet be certain, the same processes which led on Earth to the origin of life and intelligence should have been operating throughout the cosmos. There may be 1 million worlds in the Milky Way galaxy alone, which are at this moment inhabited by other intelligent beings. What a wonder, what a joy it would be to know something about non-human intelligence. And we can. Here is an exotic inhabited world, mostly covered with a liquid. We seek the dominant intelligence that lives beneath its fluid surface. This ocean of liquid water, kilometers deep, is teeming with strange forms of life. There are communities of transparent beings. There are societies of creatures which communicate by changing the patterns on their bodies. There are beings that give off their own light. There are hungry flowers that devour passers-by, gesticulating trees, all manner of creatures that seem to violate the boundaries between plants and animals. There are beings that flutter through the ocean like waltzing orchids. These are a few of the species that inhabit the water world called Earth. They're packed with information. Every one of them has a rich behavioral repertoire to ensure its own survival. But the grandest creatures on the planet, the intelligent and graceful masters of the deep ocean, are the great whales. They are the largest animals ever to evolve on the planet Earth, larger by far than the dinosaurs. Their ancestors were meat-eating mammals who migrated 70 million years ago in slow steps from the land into the waters. Whales like these humpbacks are still mammals. We humans have much in common with them. Mothers suckle infants. There's a long childhood in which adults teach the young, and there's a great deal of play. These are mammalian characteristics, vital if an animal is to learn. But the sea is murky. The senses of sight and smell, which work well for mammals on the land, are not much use here. So the whales evolved an extraordinary ability to communicate by sound. For tens of millions of years, the whales had no natural enemies. And then a new and alien and deadly creature suddenly appeared on the placid surface of the ocean. These often noisy and occasionally deadly objects first appeared in large numbers only a few centuries ago. They are artifacts manufactured by land creatures whose ancestors last lived in the oceans 350 million years ago. This particular one, however, is on a mission of understanding. It's called the Regina Maris, the Queen of the Sea, and one of its jobs is to record the sounds of whales. Some whale sounds are called songs, but we really don't know what their contents are. They range in frequency over a broad band of sounds down to frequencies well below the lowest sounds that the human ear can make out. A typical whale song lasts maybe 15 minutes, the longest perhaps half an hour. Occasionally, a group of whales will leave their winter waters in the middle of a song, and 6 months later they'll return and pick the song up at precisely the spot that they left it off. Beat for beat, measure for measure, sound for sound. Whales are very good at remembering. Other times they will come back after an absence of 6 months and the piece will have changed. A different song will be on the whale hit parade. Very often the members of the group will sing the same song together. By some mutual consensus, some collaborative songwriting, the piece changes slowly and often predictably. I'm not very good at singing the songs of whales, but here's a try. In January, a tiny fragment of a long whale song might sound like this. Whoop. In February, something like this. Whoop. And then in March, as maybe you'd predict, whoop. One additional a month. complex patterns in the songs of the whales are sometimes repeated precisely. If I imagine that the songs of the humpback whale are sung in a tonal language, then the number of bits of information in one song is about the same as the information content of the Iliad or the Odyssey. Is it just a romantic notion that the whales and their cousins, the dolphins, might have something akin to epic poetry? What might whales or dolphins have to talk or sing about? They have no manipulative organs. They can't make great engineering constructs as we can. But they're social creatures. They hunt and swim, fish, browse, frolic, mate, play, run from predators. There might be a great deal to talk about. The great danger for the whales is a newcomer, an upstart animal, only recently, through technology, become competent in the oceans. A creature called man. For 99.99% of the history of whales, there were no humans in the deep oceans. During this period, the whales evolved their extraordinary communications system. Some whales emit extremely loud sounds at a frequency of 20 hertz. A hertz, which is spelled H-E-R-T-Z, is a unit of sound frequency, and it represents one sound wave entering my ear every second. A frequency of 2000 hertz sounds and looks like this. 200 hertz like this, and 20 hertz like this, although your television set may not transmit sounds with frequencies as low as 20 hertz. The American biologist Roger Payne has calculated that there's a deep sound channel in the ocean at these frequencies through which two whales could communicate with each other essentially anywhere in the world. One whale might be off the Ross ice shelf in Antarctica and communicate with another whale in the Aleutians in Alaska. For most of their history, the whales seem to have established a global communications network. What two whales might have to say to each other, separated by 15,000 kilometers, I haven't the foggiest idea. But maybe it's a love song cast into the vastness of the deep. Now, this calculation on the range of whale communications assumes that the oceans are quiet. But in the 19th century, sailing ships like this one began to be replaced by steamships, another invention of those strange land animals. Commercial and military vessels became more abundant. The noise pollution in the sea got much worse, especially at a frequency of 20 hertz. The crew of this vessel tried consciously to keep her quiet, but when its engine is turned on, it gets very loud at a frequency of 20 hertz. Whales communicating across the oceans must have experienced greater and greater difficulties. The distance over which they could communicate must have steadily decreased. 200 years ago, a typical distance that some whales could communicate across was perhaps 10,000 kilometers. Today, on a typical day, the corresponding number is perhaps a few hundred kilometers. We have cut off the whales from themselves. Creatures which were freely communicating for tens of millions of years have now effectively been silenced. And we've done worse than that, because there persists till this day a traffic in the dead bodies of whales. There are humans who gratuitously hunt and slaughter whales and market the products for dog food or lipstick. Many nations understand why whale murder is monstrous, but the traffic continues chiefly by Japan and Norway and the Soviet Union. We use the word monster to describe an animal somehow different from us, somehow scary. But who's the more monstrous? The whales who ask only to be left alone to sing their rich and plaintive songs, or the humans who set out to hunt them and destroy them and have brought many whale species close to the edge of extinction? We're interested in communication with extraterrestrial intelligence. Wouldn't a good beginning be better communication with terrestrial intelligence, with other human beings of different cultures and languages, with the great apes, with the dolphins, but particularly with the whales? To survive, a whale must know how to do things. This knowledge is stored in two principal ways: in the whale's genes and in their very large brains. We can think of their genes and brains as something like libraries inside their bodies. The information in the DNA, the genetic information, includes how to nurse, how to convert shrimp into blubber, how to hold your breath on a dive 1 kilometer below the surface. The information in the brains, the learned information, involves such things as who's your mother, or what the meaning is of that song we're hearing just now. The gene library of whales and people and almost everybody else on Earth is made of DNA. The only function of this complex molecule is to store and copy information. We see here the set of instructions in human DNA, written in a language billions of years older than any human tongue. Each colored cluster of atoms is a letter in the genetic alphabet, the language of life. And there are billions of letters, many billions of bits of information. If you came from somewhere very different, you wouldn't be able to specify a whale or a person in a game of 20 questions with only 20 bits. But a game called 10 billion questions might just work. Every organism on Earth contains as its inheritance and legacy a portable library. And the more bits of information you have, the more you can do. The simplest organism, a virus, needs only about 10,000 bits, equivalent to the amount of information on one page of an average book. These are all the instructions it needs to infect some other organism and to reproduce itself, which are the only things that viruses are any good at. A bacterium uses roughly 1 million bits of information, about 100 printed pages. Bacteria have a lot more to do than viruses, because they're not thoroughgoing parasites. Bacteria have to make a living. What about a free-swimming, one-celled amoeba? These creatures are also microscopic, but in the realm of one-celled animals, they are giants, the whales of the microbial world. Each contains about 400 million bits in its DNA, the equivalent of about 80 volumes of 500 pages each. That's how much information it takes to make an amoeba, a creature like a small city, wandering through a drop of water. And what about a whale or a human being? Well, the answer seems to be that there's 5 billion bits. 5 billion bits of information in our encyclopedia of life, in the nucleus of every one of our cells. So if written out in, say, ordinary English, those instructions, that information, would fill 1,000 volumes. Think of it. In every one of the 100 trillion cells in your body, there's the contents of a complete library of instructions on how to make every part of you. Those cells are smart. If this were my gene library, it would contain everything my body knows how to do on its own without being taught. The ancient information is written in exhaustive, careful, redundant detail. How to laugh, how to sneeze, how to walk, how to recognize patterns, how to reproduce, how to digest an apple. If written out in the language of chemistry, what would the instructions for digesting the sugar in an apple look like? Well, let's see. Amino acid synthesis, polypeptide chains, transfer RNA, genetic code, enzyme expression, enzyme phosphorylation, we're getting warm, hexose monophosphate shunt, citric acid cycle. Here we are, anaerobic glycolysis. Now, eating an apple may seem like a very simple thing, but it's not. In fact, if I consciously had to remember and direct all the chemical steps required to get energy out of food, I'd probably starve to death. And yet, even a bacterium can do anaerobic glycolysis. That's why apples rot. It's lunchtime for the bacteria. They and we and all the creatures in between possess similar genetic instructions. Our separate gene libraries have many pages in common, which is, by the way, another reminder of the deep interconnection of all living things on our planet because of a common evolutionary heritage. Our present human technology can duplicate only a tiny fraction of the intricate biochemistry which our bodies seem to perform so effortlessly. But we're just beginning the study of biochemistry. Evolution has had billions of years of practice. The DNA knows. Now, what if what we had to do was so complicated that even several billion bits of information wasn't enough? What if, for example, the environment were changing so fast that the pre-coded genetic encyclopedia, which may have served us perfectly well in the past, is now not perfectly adequate? Why, then, even a gene library of 1,000 volumes wouldn't be enough. That's why we have brains. Like our other organs, the brain has evolved, increasing over millions of years in complexity and information content. Its structure reflects all the stages through which it has passed. The brain has evolved from the inside out. Deep inside is the oldest part, the so-called brain stem. It conducts many of the basic biological functions, including the rhythms of life, like heartbeat and respiration. The higher functions of the brain have evolved in 3 successive stages, according to a provocative insight by the American biologist Paul MacLean. You see, capping the brain stem is the so-called R complex, R for reptile. It's the seat of aggression, ritual, territoriality, and social hierarchies. It evolved some hundreds of millions of years ago in our reptilian ancestors. So deep inside our brain is something rather like the brain of a crocodile. Surrounding the R complex is the limbic system, or mammal brain. It evolved some tens of millions of years ago in ancestors who were mammals, all right, but not yet primates like monkeys or apes. It's a major source of our moods and emotions, our concern and care for the young. And then finally, on the outside of the brain, living in a kind of uneasy truce with the more primitive brains beneath, is the cerebral cortex, evolved millions of years ago in ancestors who were primates. This This is the point of embarkation for all our cosmic journeys, the cerebral cortex, where matter is transformed into consciousness. Here, comprising more than 2/3 of the brain mass, is the realm both of intuition and of critical analysis. It's here that we have ideas and inspirations, here that we read and write, here that we do mathematics and music. The cortex regulates our conscious lives. It is the distinction of our species, the seat of our humanity. Art and science live here. Civilization is a product of the cerebral cortex. Behind the forehead are the frontal lobes of the cerebral cortex. They may be the places where we anticipate events, where we figure out the future. But if we can foresee an unpleasant future, we can take steps to avoid it. Down here in the frontal lobes may be the means of ensuring human survival, if we have the wisdom to pay attention. Inside the cerebral cortex is the microscopic structure of thought. The language of the brain is not the DNA language of the genes. What we know is encoded in cells called neurons, tiny switching elements, every connection representing 1 bit of information. How many neurons do each of us have? Maybe 100 billion, comparable to the number of stars in the Milky Way galaxy. And there are something like 100 trillion neural connections. This intricate and marvelous network of neurons has been called an enchanted loom, where millions of flashing shuttles weave a dissolving pattern. Even in sleep, the brain is pulsing and throbbing and flashing with the complex business of human life, dreaming, remembering, figuring things out. Our thoughts, our visions, our fantasies have a tangible, physical reality. What does a thought look like? Well, it's made of hundreds of electrochemical impulses. Over there, for example, is a spark of a memory, maybe the smell of lilacs on a country road in childhood. And there goes a bit of an anxious all-points bulletin. Perhaps, where did I leave my keys? The neurons store sounds, too, and snatches of music. Whole orchestras play inside our heads. The landscape of the human cerebral cortex is deeply furrowed, and there's a good reason for it. These convolutions greatly increase the surface area available for information storage in a skull of limited size. The world of thought is roughly divided into 2 hemispheres. Over there is the right hemisphere of the cerebral cortex. It's mainly responsible for pattern recognition, intuition, sensitivity, creative insights. And over here is the left hemisphere, presiding over rational, analytic, and critical thinking. These are the 2 sides, the dual strengths, the essential opposites that characterize human thinking. Before us are the means, both for generating ideas and for testing their validity. There's a continuous dialogue going on between the 2 hemispheres of the brain, channeled through this immense bundle of nerve fibers, which is called the corpus callosum. It's a bridge between creativity and analysis, both of which are necessary if we're to understand the world. The information content of the human brain, expressed in bits, is probably comparable to the number of connections between the neurons in the cortex, about 100 trillion bits, 10 to the 14th connections. If written out in English, it would fill some 20 million volumes, as many as in the world's largest libraries. The equivalent of 20 million volumes worth of information is inside the heads of every one of us. The brain is a very big place in a very small space. Most of the books in the brain are up here in the cerebral cortex. Down there, in the basement of the brain, are the functions that our remote ancestors mainly depended on for survival. Aggression, child rearing, sex, the willingness to follow leaders blindly, lots of things that we can still recognize in our lives today. Of the higher brain functions, some of them, like reading, writing, speaking, seem to be located in particular places in the cerebral cortex. On the other hand, each memory seems to be stored in many separate locales in the brain. Old memories are in lots of places. Here's one of my earliest memories.
That's a good boy. Lunch is almost ready.
That was a long time ago. But its imprint has not faded in the library of this brain. But the brain does much more than just recollect. It intercompares, it synthesizes, it analyzes, it generates abstractions. The simplest thought, like the concept of the number 1, has an elaborate logical underpinning. The brain has its own language for testing the structure and consistency of the world, but we never see the machinery of logical analysis, only the conclusions. There's so much more that we must figure out than the genes can know. That's why the brain library has 10,000 times more information in it than the gene library. Our passion for learning is the tool for our survival. And unlike the musty bindings of our gene library, in which hardly a word changes in a century, the brain library is made of loose-leaf books. We're constantly adding new pages and new volumes. Emotions and ritual behavior patterns are built very deeply into us. They're part of our humanity, but they're not characteristically human. Many other animals have feelings. What distinguishes our species is thought. The cerebral cortex is, in a way, a liberation. We need no longer be trapped in the genetically inherited behavior patterns of lizards and baboons, territoriality and aggression and dominance hierarchies. We are, each of us, largely responsible for what gets put into our brains, for what, as adults, we wind up caring for and knowing about. No longer at the mercy of the reptile brain, we can change ourselves. Think of the possibilities. The city, like the brain, has evolved in successive stages. The vestiges of its past are still retained among the constructions of the present. A city like New York developed from a small center and slowly grew, leaving many of the old parts still functioning. Some of the major streets date to the 17th century, its commercial hub to the 18th century, the water and gas works to the 19th, the electrical and communication systems to the 20th century. The city has evolved much faster than the brain. Only 10,000 years ago, the human brain looked exactly as it does today, and we were just as smart. But there were no cities, only a few scattered encampments in the vast primordial forests. Today, it's just the opposite. Forests and grasslands often seem like scattered islands in a sea of cities. If you were an observer from an alien world, you would have noticed that something very complicated has been happening here over the last few thousand years. It might take you a while to figure out the details, but you would recognize by its complexity unmistakable evidence for intelligent life. On closer scrutiny, you might even be able to recognize individual intelligent beings. The evolution of the city is due to their conscious activity. Millions of human beings working more or less together to preserve the city, to reconstruct it, and to change it. It might be more efficient if all civic systems were periodically replaced from top to bottom. But as in the brain, everything has to work during the renovation. So the city mostly adds new parts while the old parts continue, more or less, to function. For example, in the 17th century, you traveled between Brooklyn and Manhattan across the East River by ferry. In the 19th century, the technology became available to construct a suspension bridge across the river. It was built precisely at the site of the ferry terminal because major thoroughfares were already converging there. Later, when it became possible to construct a tunnel under the river, that too was built in the same place and for the same reason. This use and restructuring of previous systems for new purposes is very much like the pattern of biological evolution. Or consider 3rd Avenue. In the 17th century, you made your way uptown on foot or on horseback. A little later, there were coaches, the horses prancing, the coachmen cracking their whips. And then these were replaced by horse-drawn trolleys clanging along fixed tracks on this avenue. Then electrical technology developed, and a great elevated railway line was constructed called the 3rd Avenue L, which dominated this street until 1954, when it was utterly demolished. Anyway, the L was then replaced by buses and taxi cabs, which still are the main forms of public transportation on 3rd Avenue. Now, as gasoline becomes a rare commodity, the internal combustion engine will be replaced by something else. Maybe public transport on 3rd Avenue in the 21st century will be by, I don't know, pneumatic tubes or electric cars. Every step in the evolution of 3rd Avenue transport has been conservative, following a route first laid down in the 17th century. But the brain is still more conservative than the city. If this were the brain, we might have horse-drawn trolleys and the L and buses, all operating simultaneously, redundantly, competitively. The vestiges of earlier history clearly in evidence. When our genes could not store all the information necessary for our survival, we slowly invented brains. But then the time came, maybe tens of thousands of years ago, when we needed to know more than could conveniently be stored in brains. So we learned to stockpile enormous quantities of information outside our bodies. We are the only species on the planet, so far as we know, to have invented a communal memory. The warehouse of that memory is called the library. Libraries also have evolved. The Assyrian library of Assurbanipal had thousands of clay tablets. The celebrated library of Alexandria in Egypt consisted of almost 1 million papyrus scrolls. Great modern libraries, like the New York Public Library, contain some 10 million books. That's more than 10 to the 14th bits of information in words. More than 100 trillion bits. And if we count pictures, it's something like 10 to the 15th bits of information. Now, that's more than 10,000 times the total number of bits of information in our genes. Something like 10 times the total amount of information in our brains. If I were to read a book a week for my entire adult lifetime, and I lived an ordinary lifetime, when I was all done, I would have read maybe a few thousand books, no more. In this library, that's from about here roughly to about here. But that's only 0.1% or so of the total number of books in the library. The trick is to know which books to read. But they're all here. What an astonishing thing a book is. It's a flat object made from a tree with flexible parts on which are imprinted lots of funny dark squiggles. But one glance at it and you're inside the mind of another person. Maybe somebody dead for thousands of years. Across the millennia, an author is speaking clearly and silently inside your head, directly to you. Writing is perhaps the greatest of human inventions, binding together people who never knew each other, citizens of distant epochs. Books break the shackles of time. A book is proof that humans are capable of working magic, and this room is filled with magic. Some of the earliest authors wrote on bones and stones. Cuneiform writing is the remote ancestor of the modern Western alphabet. It was invented in the Near East about 5,000 years ago. Its purpose? To keep records. Records of the purchase of grain, the sale of land, the triumphs of kings, the statutes of priests, the positions of the stars, the prayers to the gods. This cone was made around the year 2350 BC. 4,300 years ago, there were people chipping and chiseling away the message on this cone. What is that message? It's a prayer. The inscription on this cylinder honors a king, Nebuchadnezzar, king of Babylon, in the 6th century BC. For thousands of years, writing was chiseled into stone, scratched onto wax or bark or leather, painted on bamboo or silk or paper, but always in editions of one copy at a time. Always, except for inscriptions on monuments, for a tiny readership. But then, in China, between the 2nd and the 6th centuries, paper, ink, and printing with carved wooden blocks were all invented more or less together, permitting many copies of a work to be made and distributed. This is Chinese magic from the 12th century. It took 1,000 years for the idea to catch on in relatively remote and backward Europe. Just before the invention of movable type around the year 1450, there were no more than a few tens of thousands of books in all of Europe, every one of them handwritten. 50 years later, there were 10 million printed books in Europe. Learning became available to anyone who could read. Suddenly, books were being printed all over the world. Magic was everywhere.
It is 23 centuries since the founding of the Alexandrian Library. Since then, 100 generations have lived and died. If information were passed on merely by word of mouth, how little we should know of our own past. How slow would be our progress. Everything would depend on what we had been told, on how accurate the account. Ancient learning might be revered, but in successive retellings it would become muddled and then lost. Books permit us to voyage through time, to tap the wisdom of our ancestors. A library connects us with the insights and knowledge of the greatest minds and the best teachers, drawn from the whole planet and from all our history, to instruct us without tiring and to inspire us to make our own contributions to the collective knowledge of the human species.
There's a fair number of Gutenberg Bibles and first folios of Shakespeare in the world, but most of the books you see in front of you are limited editions with very few surviving copies. But there also exists in the world mass printings of paper-bound books that I think are still more wonderful. For the price of a modest meal, you get the history of Rome. Books are like seeds. They can lie dormant for centuries, but they may also produce flowers in the most unpromising soil. These books are the repositories of the knowledge of our species and of our long evolutionary journey from genes to brains to books.
Libraries in ancient Egypt bore these words on their walls: nourishment for the soul. And that's still a pretty fair assessment of what libraries provide. Even at night, the city, like the brain, is busy assimilating and distributing information. Information keeps it alive and provides the tools to adapt to changing conditions. The long human journey from genes to brains to books. Information itself evolves, nurtured by open communication and free inquiry. The units of biological evolution are genes. The units of cultural evolution are ideas. Ideas are transported all over the planet. They reproduce through communication. They are selected by analysis and debate. In the last few millennia, something extraordinary has been happening on the planet Earth. Rich information from distant lands and peoples has become routinely available. The number of bits to which we have access has grown dramatically. Computers can now store and process enormous amounts of information extremely rapidly. In our time, a revolution has begun, a revolution perhaps as significant as the evolution of DNA and nervous systems and the invention of writing. Direct communication among billions of human beings is now made possible by computers and satellites. The potential for a global intelligence is emerging, linking all the brains on Earth into a planetary consciousness. Elsewhere, there may be brains, even planetary brains, but there will be no brains quite like ours. Mutation and natural selection are basically random processes. If the Earth were started over again, intelligence might very well emerge. but anything closely resembling a human being would be unlikely.
On another planet with a different sequence of random processes to make hereditary diversity and a different environment to select particular combinations of genes, the chance of finding beings very similar to us must be close to zero. But the chance of finding another form of intelligence isn't close to zero. Their brains may well have evolved from the inside out as ours have. They may well have switching elements analogous to our neurons, but their neurons might be very different. Maybe they're superconductors which work at very low temperatures, in which case their speed of thought might be 10 million times faster than ours. Or perhaps their neurons are not in direct physical contact with each other, but in radio communication, so a single intelligent being could be distributed among many different organisms. There may be planets on which intelligent beings have not 10 to the 11th neurons each as we do, but 10 to the 20th or 10 to the 30th. I wonder what they would know. If we could make contact, there would be much in their brains that would be of enormous interest to ours.
And vice versa. I think extraterrestrial intelligence, even beings astonishingly more evolved than we, will be curious about us, about what we know, how we think, the course of our evolution, the prospects for our future. Within every human brain, patterns of electrochemical impulses are continuously forming and dissipating. They reflect our emotions, ideas, and memories. When recorded and amplified, these impulses sound like this. But would an extraterrestrial being, no matter how advanced, be able to read the mind that made these sounds? We ourselves are far from being able to do so. But in fact, we have sent the very impulses you are hearing, reflecting the emotions, ideas, and memories of one human being, on a voyage to the stars. In August and September 1977, 2 Voyager spacecraft were launched on an epic journey to the outer solar system and beyond. Their scientific mission was to explore the giant planets. First Jupiter and its satellites, and then Saturn and its system of moons. Close encounters with these great worlds accelerate the Voyager spacecraft out of the solar system. As an incidental consequence of their trajectories, they will be carried inexorably into the realm of the stars, where they will wander forever. The ships will be slightly eroded within the solar system by micrometeorites, planetary ring systems, and radiation belts. But once past the planets, they will endure for 1 billion years in the cold vacuum of interstellar space. Perhaps in the distant future, beings of an alien civilization will intercept these ships. They will examine our spacecraft and understand much about our science and technology. But a machine alone can tell only so much about its makers. So each bears a golden phonograph record with not only the brainwaves of a woman from Earth, but also an anthology of the music and pictures and sounds of our planet, including greetings in 60 human languages and the salutations of the humpback whales. The record cover bears instructions on how to hear the sounds and see the pictures encoded on the disc, including some snapshots from the family album of a distant world. The Voyager record is a message in a bottle cast into the cosmic ocean. It contains some of our thoughts and our feelings, something of the information we store in genes and brains and books. The recipients, if any, will understand the pictures and sounds incompletely at best. But one thing would be clear about us. No one sends such a message on such a journey without a positive passion for the future. For all the possible vagaries of the message, they will be sure that we were a species endowed with hope and perseverance, at least a little intelligence, and a longing to make contact with the cosmos.